we're back to finish up this question. It's question 4, part B, and now we're doing parts B and C of that question. And part B wants you to find the minimum temperature at which the reaction is spontaneous. For spontaneous, delta G has to be negative. So we can find that minimum temperature by setting delta G to 0 and using our equation where we had delta G equals delta H minus T delta S. And in part A, we calculated delta H and delta S. So just by setting that to 0 here and solving for the temperature, we end up with a value of 671 Kelvin. You have to at least be above that temperature in order to have a spontaneous reaction. Oh, sorry, this is B, not C. Part C, in this case here, they're going to calculate the equilibrium partial pressure of CO2. So at 298 and at 1200 Kelvin. So we're talking at equilibrium here. So equation relating delta G at equilibrium, delta G equals minus RT ln K. And K in this case here, remember K is going to be the concentration of the products over reactants. If anything is solid, it is not included in this equation. And if anything is a gas, it's included as a partial pressure, and those are found as bars if there's only one. So we have partial pressure of CO2 is all that we have for K. So by solving for K, we're going to solve for the partial pressure of CO2. So by rearranging that equation, this is going to be equal to E to the minus delta G naught over RT. And we're going to do this at 298 and at 1200. One thing to really pay attention with here is that our delta G values are in kilojoules and R is generally present in joules. So just make sure that you're doing the proper conversion, one or the other, whatever it is, make sure your units cancel because that's one area where we see issues. So at 298, you should get a value of, remember this is partial pressure of CO2, this is 3.72 times 10 to the minus 12 bars. So this is a very, very small number. Remember at 298, it's also a non-spontaneous reaction. And at 1200, you're going to have a value of 1.05 times 10 to the 4 bar. There you go.